So number 5, given this function, and they're telling us 2i is a 0, write p in factored form as a product of linear factors. Be sure to write the full equation, including p of x. Okay. So this is going to be a long one. So step number 1 is to graph p of x and find one or more zeros right on the graph. So here's the notes. Here's the exam 3 notes. I'm going through this. Step 1, when you're trying to find all the zeros here, step number 1 is to graph at geogebra.org. Find 1 0 or maybe more than one, then do synthetic division, then do the quadratic formula. So their notes are all there. And I even show how to write factored form at the end, very bottom. If asked to write in factored form, x minus each 0. There it is. So, all right. So that's what we'll do at the very end. So graph at geogebra.org. So I'm going to graph this function. I'm going to cruise on out now to geogebra.org. Let's go there. Okay, I'm going to put in a new function. Maybe I could just use what I got here. What do we have? We have 3x to the 5th. So I'll just kind of fix this one. Oh, we need 3x to the power 5. So do those powers, you got to hit shift up arrow, which is shift 6. And then you're in the power zone. See, I'm up in the power zone right now. And so if you want to start typing back on the baseline, you got to hit right arrow or tab to bring yourself back down to the baseline. Plus 14x to the 4th, shift up arrow, 4th power, right arrow, plus 29x cubed, 62x squared. I'll put that in there. 62x squared, 68x. 68x, and what's the last one? Plus 24. Boom. There we go. All right, so look at the graph. Look at how there's 3 real zeros. So this is a 5th power function. So we're going to have 5 zeros altogether. Looks like 3 of them are real. 2 of them must be imaginary. You tracking with me? See how I'm concluding all that? This is a 5th power function. So it's going to have 5 zeros. You always have the same number of zeros as you do power. So 5th power, 5 zeros. And I'm looking at the graph and I'm seeing three places where it hits the x-axis. 3 zeros that are real. That means there must be 2 that are imaginary because there's a total of 5. What are these guys? This is -3. This one's -1. And this one is something a little more ugly. So I'm just going to use the 2 that are obvious, the -3 and the -1. Those are easy numbers, clearly zeros, -3 and -1. The other one's some kind of decimal thing. You could probably figure it out, but let's just go with -1 and -3, and I'll just use those to start off with. All right, back to the workboard, the iPad, -3 and -1. Let's go do that. All right. So -3 and -1. So I found those zeros. X equals -3 and x equals -1. Those are 2 of the zeros. Are zeros from the graph, -1 and -3. Okay, so what are you going to do? Now comes synthetic division, but we're going to do it twice. Actually, more than twice. I'll show you. We're going to have a big, long synthetic division problem here. Here we go. So synthetic division like crazy. So write it over here. Whoops, mess that up. Okay, I probably didn't make that long enough. Bring down, so start, you can start with the -3 or the -1, it doesn't matter. I'll just grab the -3, whatever. You could start with the -1, it doesn't matter at all. Just start with one of those 2. Okay, and you might be wondering, what about the 2i? I'll get to that in a little bit. It's easier to start with these real ones. So let's start, so I'm gonna bring these guys down. So there's the 3, 14, 29, the 62, the 68, and the 24. Okay, and you know how this is going to work. This last spot is going to be the remainder 0. Okay, what do you do? Remember what you do. You bring this guy down, and then you multiply. Multiply and write the answer right there. Minus 3 times 3 is a minus 9, and then you what? Add them up. So 14 minus 9 is what? 5. And then you do it again. You multiply. Minus 3 times 5, and you write the answer right there. Minus 15, and you add them up. 29 minus 15 is what? 14. And then you multiply. Minus 3 times 14, use your calculator if you need to, is minus 42. And then add them up. It's going to be 20. And 2 more here. Again, we're going to multiply. Minus 3 times 20 is minus 60. And then add them up. And this is 8. Last step. Remember what's supposed to happen on the last step is a good double check. Minus 3 times 8 is minus 24. Add them up. 0. Perfect. You're supposed to get a 0 remainder. If something is really a 0, like x equals negative 3 is really 0, then when you divide, you get remainder 0. Check. That means we didn't mess anything up. So that's all. It's very reassuring. I like that. Okay. So where are we at? So that means that's our first one. We have a lot more to go. So that means that so far with this function, we have divided by the negative 3. So now we need to do it again. We got to keep going with synthetic division. So this is going to be a long synthetic division problem. So I'm going to come down and do synthetic division again. And like this, and I'm going to bring down these coefficients. 3, 5, 14, 20, and 8. And this line's going to move over. Oops, right there. Okay. And what are you going to divide by now? Well, what other 0 did we have? Negative 3 was a 0, but so is negative 1. So now I'm going to use negative 1 because that's another 0. So I'm dividing. So I divided the whole original function right up here. I divided, right, here's the whole original function, which I put right there. Right, see all those arrows bringing it down? So the whole original function, wrote it right there and divided by negative 3, got this answer. And then I take the answer and now I divide by the other 0, negative 1. I just keep breaking it down further and further. Here we go again. Bring down the 3. Multiply. And that will be what? Negative 3. Add them up. 2. Swing it around again. Multiply. Negative 1 times 2 is negative 2. Add them up. 14 minus 2 is 12. Swing it around again. Negative 1 times 12 is negative 12. Add them up again. 8. And last time, you know what's supposed to happen here? Multiply negative 1 times 8. Sure enough, negative 8. Add them up. 0. That's beautiful. Whoop, I bumped it. That's not beautiful. Remainder, check. So in other words, we successfully divided by negative 3 and then took that result and divided by negative 1. Okay. So this is really working out. Now, what do we have so far? So let me tell you where we're at so far in this problem. We have the original function, which is p of x right there. We have p of x equals Remember, x minus -3 and x minus -1. Remember, it's always x minus 0, 1 and x minus 0, 2. Doesn't matter what order you put them in. So I've got -3 and -1. There's 2 more zeros. And then what does that leave? Well, that leaves these guys, which are what? Well, this must be 3. Now, what power are we at? Well, we've divided twice. So we started with 5th power, and we've divided twice, down to 4, down to 3. So this is 3rd power. Every time you divide by something with an x, you lower the power of x by 1, of course. So we started with 5th, we divided by x twice, we're down to the 3rd power remaining now. So this is 3x to the 3rd plus 2x plus 12. Oh, and this should be, sorry, x squared plus 12x plus 8. There we go. So we get to there so far. That's what's happening. Every time, so every zero that we have, -3 and -1, which we got right off the graph, we just divided both by the -3 and got this result, and then took that result here and divided by the -1. After both divisions, this is our result, this result right here. So that means we factored down so far the first 2 zeros, and this is what remains after the first 2 zeros are removed. Okay, now we got to break this down further, and we cannot do the quad on that. Right? You with me? Let me say why. This is 3rd power. X to the 3rd cannot use the quadratic formula. You got to be down to x squared to use the quadratic formula. So what am I going to do then? How am I going to break, cannot use the quadratic formula yet, only x squared. So what are we going to do? Well, that's why they gave us another 0 right here. See this? 2i. They told us 2i is a 0. Oh, okay. So now we're going to use that. That means we can do synthetic division yet again. Let's do it. I'm going to come in here. I'm going to do synthetic division again. And I'm going to bring down these coefficients. So 3, 2, 12, and 8. And draw my line right here like usual. And what am I going to divide by? The other 0. What's the other 0? 2i, right? They told me that right here. 2i is a 0. 2i is a 0. So let's put in the 2i and divide again. Anytime you have a 0, you can divide by that thing. It's guaranteed to come out with a remainder 0. All right, remainder 0 right there in a vote of confidence that I'm sure it's going to work. I sure hope so. So here we go. What do? You bring down the 3. Then you do what? You swing it around. You multiply. Now what's 3 times 2i? Well, 6i. Let me change the color there. It's 6i. And then you what? Add these up. So that's weird. This is going to be 2 plus 6i. You can't add those. You can't make that 8i, right? That's not 8i. If it was 2i and 6i, then it would be 8i. But it's not. The 2 doesn't have an I. So it just stays separate. 2 and 6i are unlike terms. They can't add. Okay, well, then what? Well, then you just do it again. 2i is going to multiply. Now, how does he multiply 2 things? He just multiplies both of them. So it's going to be, maybe I should show that on the side, or I don't know where to do it. Here, I'll do it over here. 2i times 2 plus 6i. Yeah, I'll just show right here. Boom, boom. What happens? 2 times 2 is 4i. 2 times 2, and then 2 times 6 is 12i squared. Is that good so far? So I'm just multiplying 2i times 2 plus 6i, right? 2i is multiplying 2 plus 6i. I'm doing it over here. That's 4i plus 12i squared. Now, do you remember what I squared does? Remember, I squared is -1. Maybe it's been a little while. You never leave I squared. Regular I we just leave as regular I. We don't mess with that. But I squareds we never leave. Those are just -1. I squared's just -1. Why? Well, I don't have time right now. Let's just keep moving. I squared is -1. So what are we going to do? This is 4i minus 12 then. That's 4i minus 12. So I'm going to write that. 4i minus 12 and add them up. What do you get? Well, these 12s cancel. And you just get 4i, right? And then last one, we know what we're supposed to get. Multiply 2i times 4i. Now, how does that work? You do it right over here. 2i times 4i. Well, that's 8i squared. And remember, what is I squared? -1. So that's -8. And that's what it's supposed to be. Perfect. Add them up. 0 remainder. This is beautiful, isn't it? It's like a plan. Check. It worked. It worked. So, okay, now what do we got? So now we have the function p of x. Let's write where we're at. This is a long one. P of x equals. So remember, x minus -3, x minus -1, x minus -3, x minus -1. Now x minus 2i, that's the third 0, 2i. Okay, let me get rid of this out of the way here. And then what's left? What's left is this, this, and this. In fact, rather than do that, I'm just going to write, it's just 3, it's 2 plus 6i, it's 4i. I know it probably seems weird to you. This is actually x squared. This is actually x. It's like that. We need to do one more step. Let's just do one more synthetic division step. I know it probably seems really strange, this last synthetic division step, but it's really the same as the others. Higher here. Okay. What do you mean? What are we going to do on the last step? Well, here's an important principle that you need to know to finish this problem. Whenever you have 2i being a 0, guaranteed also -2i is a 0. Basically, if you have an imaginary 0 for a function, there's a formula, there's a theorem that says if you have an imaginary 0, technically it's called a complex 0, then the opposite sign is also a 0. The opposite sign on the imaginary part. Opposite sign on the I. The opposite sign on the I is also a 0. It's called the complex conjugate. You might have a T. So basically we're saying if you have A plus BI, then if A plus BI is a 0, then A minus BI is also a 0. Now, we didn't have any A. Our A was 0. We didn't have a real number part. We just had the BI. We just had the -2i. So that, we had the +2i. So that means that -2i is also a 0. Is this making any sense? There's a theorem that says, and we need to know this theorem, that whenever you have an imaginary called complex 0, like +2i, then automatically the opposite sign -2i will also be a 0. The opposite sign on the I, called the complex conjugate. Conjugate means change the sign in the middle. See how it's changing the sign on the I part? Positive BI becomes negative BI, changing the sign on the I part. That is automatically also a 0. That's always true. There's a theorem that's proven it. Okay, so what? Well, that means coming down here that now I can also divide by -2i, right? I did +2i. I can also do -2i. That'll work also. That'll be a 0 also. The opposite sign on the imaginary part is also a 0. If 2i is a 0, then -2i is a 0. Guaranteed. What coefficients go in here? What was left? 3. 2 plus 6i, 4i. And we know what we're expecting. Got to get a 0 there, right? Whoops, it's a box. So I'm in the tool mode. Got to be a 0 there. 0 remainder. It better be. All right, this is the last one. Let's do it. I don't know if you've had enough yet, but here we go. Bring down the 3 and swing it around. Multiply. Oops. Multiply. Negative 2i times 3 is negative 6i. Add them up. These will cancel. And it's just 2. That's nice. And then multiply. Negative 2i times 2 is negative 4i. Add them up. Sure enough, 0. Beautiful. So, okay, so where in the world are we then? This means our function p of x is x minus the first 0 that we saw on the graph, and then x minus the second 0 that we saw on the graph. And x, oh, I'm just running out of room here. I'm going to have to make this a lot smaller because we're basically done. All right, p of x equals x minus negative 3, x minus negative 1, x minus 2i, x minus negative 2i, and finally these guys. What are those guys? Well, where are we at? We're down to the first power now, right? We've divided by 1, 2, 3, 4 x's. We started with x to the 5th right here, and we divided by 4 x's. So we're only left with x to the 1st. So these guys right here are 3 x to the 1st plus 2. 3 and plus 2. That's the last term, and there it is. There's our answer. We broke down, and if you want to change the way it looks, you could do that. You could say p of x. You want to say, well, isn't that just x plus 3? Yeah, sure. If you want to do that, feel free. X plus, you don't have to. You type it in either way. X minus 2i, and these double negatives here will be x plus 2i. And then the last one, 3x plus 2. There it is. We broke down that entire original function, which was x to the 5th and blah, 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 all that stuff. We just did it all the way. How did we do it? Let me recap real quick. That was a long one. So what we did here on this problem is, starting from the beginning, they gave us x to the 5th. We were expecting 5 zeros. They want us to factor it. Okay. And so we said, okay, we went to the graph and we saw that negative 3 and negative 1, you can still read those, were both zeros. So then I took the original function p of x right here, and I divided by negative 3. Oh, and then I got this answer. So we just keep dividing, getting an answer, and then we take that answer down and we divide again. We broke it down again, this time by negative 1, the other 0 we got from the graph. And I got this answer. And then I took that eventually down here and divided by the other 0, the imaginary one they told me, 2i. They said it right in the words of the problem. And I got this, and then I took that and divided by negative 2i, because we have that theorem that anytime an imaginary 0 exists, its opposite exists. So if 2i is a 0, then negative 2i is a 0. So I divided by negative 2i. Notice all these came out with the remainder 0, and I got 3x plus 2. And I knew I was down. How did I know this was 3x plus 2? Because I was down to the first power at that point. I had divided by 1, 2, 3, 4 x's. X to the 5th, dividing out 4 x's only leaves x to the 1st. So that was 3x plus 2. They're both positive. So 3x plus 2. So there it is, x minus the first 0, x minus the second 0, x minus the third, x minus the fourth, and the last remainder quotient. So there it is, all factored down.